If you are looking to get started with machine learning, but have very little to no coding experience, then you have come to the right place. Now, this will be a little bit easier to understand if you have coded a little bit, especially in Python, because that's the language that I'll be working in. However, if you haven't coded before, there's still a good chance that a lot of these concepts will make sense and you'll be able to synthesize this information. And if not, you can actually go in the link below, and because I'm offering tutoring sessions to help people, to teach people basically enough Python to feel comfortable doing a small project like this. So getting that out of the way, let's get into this. So I'm going to explain kind of what these first two lines of code here do before going in any further. So import pandas as PD. So pandas is a package within Python. So if you can think about it, say you're the person building machine learning models or a data scientist, right? You're like riding a motorcycle, and Python is the motorcycle, and pandas could maybe be like the helmet. So it's like, you know, it's not directly part of Python, but it goes hand in hand with Python. And it does a lot of really cool stuff, which you'll get to see that here throughout this video. And then this line, df equals pd.read CSV, with all that is the data set that we're working with. And I have it on my computer, but to get the data set to follow along, you can simply go search in World Happiness Report on what's a website called kaggle.com. And also to have the technology to do this as well. I probably should have mentioned this first, but we have what's known as Anaconda. So let me show you. It's really simple. Just you can just Google in Anaconda. I guess depending on, you know, what search history you have and how they target you on Google, it might be the first thing that comes up, but it's anaconda.com. The installation process takes about like 15 minutes. It's not really that difficult. So if you want to follow along, I'd advise pausing the video and going ahead and getting that stuff set up so you can follow along. So before we get into the machine learning, a common practice in data science and a best practice is to always explore your data and kind of like look for patterns within your data set before you get into machine learning. Now, if this was a real project, a lot of data scientists would actually spend a whole day doing this kind of stuff before actually building any models, because in general, building models without understanding your data is just really bad practice. However, this is kind of a more training wheels video, so I'm just going to show you two really common charts and visualizations and how to make them. So the first one I'm going to explain is the scatter plot. You've probably seen them in math class before. It's like there's like a chart with a bunch of dots on it, and you find the correlations between them. Anyway, I'm going to show you how to make one in Python. So we're going to have another package here. So if we've got a motorcyclist, maybe this in the pandas is the helmet. Let's say this is maybe the I don't know, the leather jacket or something. And the reason why I'm doing the as PLT thing is so that every time I use it, I don't have to write out that whole thing, because that would just kind of be annoying. So we're going to have a scatter. That's all you have to do is plt.scatter. And again, if you want to know like the more in-depth things and more in-depth details about why things are structured like this and why it's syntaxed this way, that's definitely something I'll cover in later videos, as well as in my tutoring sessions. Anyway, so we've got an X and a Y. So let's say we want to look at, let's compare social support to generosity. So generosity is like how much foreign aid the country gives or receives. And then social support is measures of how well social services and things like kind of like Medicare and things like that of that nature are put into place in the country. And as you can see, generosity is mostly, we've got Denmark, Switzerland, Iceland, like Northern European countries have higher generosity. You look at these countries in the bottom here, we've got all these African countries that are low. However, it's interesting because Rwanda has a positive generosity and Finland actually has a slightly negative. My guess would be like maybe some natural disaster recently happened in Finland and like their buddies in Norway had to give them some money or something like that. But anyway, let's see this. So we're going to compare the columns, and to select a column, you call the df, which is the name of the data set, and then you take the column name. So our X, let's say our X is generosity, like our independent variable is generosity. And we're wondering how generosity maps onto social services within the country. Generosity. And then we've got and watch what happens. We get an error. Now, why do we have an error? Because it says key error social services. And the reason for that, if you go up here, social services, social support, my bad. Social support, that's what happened. I called it social services. So social services is not a thing here. It's support. However, this will not work either, and you're about to see why. Because I capitalized support. Social support is lowercase. And Python is extremely case sensitive, so that is just something to be on the lookout for. There we go. So as you can see, there's not really tons of correlation here. It just seems to be that a lot of countries do pretty good at providing social services, but are not very good providers of financial aid, or not financial aid, but foreign aid, I guess, same kind of concept. So to make this, and as you can see, it's kind of confusing with these numbers. So to make it a little more comprehensive, or easy to understand, we have these X label and Y label functions. So we're going to call this generosity, and we're going to call Y label, I don't need to copy this. And we're going to call this social support. I can call it anything I want and there won't be any errors though. I could call it like Jedi Master and Yu-Gi-Oh for all it cares. But yeah, so that is how that works. Now, the next one we're going to do is a bar plot. So this was categorical data, which means we're working with purely numerical data, but this is not always the case. So in this case, I'm going to show you how to make a bar plot, and this will be using categorical data. And our category is the region of the country. So as you can see, we got countries in Western Europe, Sub-Saharan Africa, and South Asia, just to name a few. So we're going to select regional. That's what they're calling it, regional indicators. So, and we're going to use a pandas function called value counts. So it's already counted it for us, right? We've got 36 sub-Saharan African countries, 21 Western European countries. The problem is it's boring. Like, look at this. This is just numbers and words. Like, it's just so boring looking. We want a colorful display. I mean, come on. So I'm going to show you how to do that. Now, first of all, let's assign this to a name. So assign this to a variable. So now, every time I type VC, it's going to show that instead of having to type this whole thing. And when you want to create something and then use it later, you always have to name it. So that way it'll just save you a lot of headache. And a lot of times programmers often forget to assign what they use to a variable name. And if you do that, basically, it's like turning in a test without putting your name on it. You can't pass the test if you don't have your name on it, even if you get everything right, because the teacher doesn't know it's your test. Anyway, hope that analogy made some sense. Anyway, yeah, so we got the same thing. It's just under a different title. Now we're going to turn this into a different data type. So right now it is a pandas core series, which is kind of like an odd data type native to pandas, but we're going to turn this into a dictionary. So dict is a dictionary is a data type. All you have to do is type in dict and put whatever you want to make a dictionary into parentheses. So I'm going to show you what a dictionary looks like real quick. And by the way, I run code using Shift Enter, although there is this run code button. I just think Shift Enter is much easier. So now we've got the dictionary. So in a dictionary, just a little Python 101 here. We got keys. So we've got, which in this case is the region, and then values, which is how many countries are in the region. But the keys and values can be anything. It could just as equally, you could have a numbers for the keys and regions for the values. It's just whatever's on the left is the keys, whatever's on the right is the values. So we're going to make an X and a Y for our graph. Our X variable is going to be the region. So that is, we're going to make lists, which is another data type in Python. We're going to make a list of VC dot keys. And you have to have parentheses at the end. And again, when you learn Python basics, wherever you learn it, that all these dot keys and all these like little syntax things will start to make a lot more sense. The point of this video is more to get you guys like excited about machine learning and getting into data science and that kind of thing. Because I know for me, I was much more motivated to learn all these ins and outs of Python when I saw like these very actionable, like hands-on tutorials, even though I was just like copying the code and then running the models. That's fine as long as you at some point pretty soon go back and actually learn Python. So anyway, there we go. We have our list, and now the list will show you what they look like. It's basically, they're put in brackets. You can access a certain element from the list. It's just be sure, you know, if we take the 0th element, we get Sub-Saharan Africa. The thing is to be sure about is just to be sure, in programming, we start counting at 0. So even though there's 10 regions, like there's 10 regions, right? There's 10 regions, but if we take the 10th region, like call x of 10, right? It won't work because it stops counting at 9 because it started counting at 0. It's kind of like the American school system. We have 13 years of school, but it's like kindergarten through 12th grade, because kindergarten, it starts at kindergarten instead of first grade. So it's kind of like that. Anyway, enough of that. Let me actually show you what it looks like. So yeah, so X and then Y. Now the problem is it looks pretty ugly. You can't read that. Look, just looks like it's a bunch of text piled on top of each other. So the workaround here. So now let's make this dirty pile of mess actually make sense. So the way we do this real quick is we integrate matplotlib and Seaborn and using them together. So we have the fig and the ax, which is axis basically. And we're going to use the matplotlib with plt dot subplots. And we're going to set it to 30 by 15, which basically means we're just going to make it bigger, so that when it gets enlarged, it will the text will obviously be more readable. And now let's add axis as a parameter. Just an FYI, when you put things inside of parentheses, it is they're called parameters. And when you do that, it's a function. You are working with a function. So bar plot is a function, and x and y are parameters, and then ax is a keyword argument, which is basically an optional parameter that you can put in there if you want to. Anyway, let's look at its improvement. And the drawback is it can get a bit large. But anyway, as you can see, we have the regions, and again, it's still not ideal really, but you can definitely see, if you look closely enough, you can actually read them as opposed to just a bunch of text stacked on top of itself. Thank you for watching this far, if you have, and I'm about to. All right, so I went ahead and already wrote most of this code here, but I'm going to walk you through it. So the first thing we did here was our import statements. Now, scikit-learn is a really widely used machine learning package in Python. Data scientists and all sorts of people that use machine learning are quite familiar with it. And anyway, so we're importing the most simple model from scikit-learn, which is the linear regression model. And the funny thing about it is it's actually it's the exact same thing pretty much as y equals mx plus b from math class. The only difference is it can take in multiple variables. So it's like, because instead in math class it was just x and y, but instead there's like unlimited number of x's, if that makes sense. And then we've also imported the train test split function, or class, I guess you could call it. And the train test split is essentially, when we're doing machine learning, we don't train the model on all of the data. We only train it on about 70 to 80% of the data, and then we test it on the remainder. And the reason for that is because we want to make sure that the model is actually learning how to predict values rather than just memorizing it. Kind of like in math class, you get a study guide with like algebra or pre-calculus questions, and then you get a test that's similar, the same topic but different questions to make sure you're remember, you're actually learning the information and the material and not just memorizing stuff. So the next thing that happens is the data has to get manipulated a little bit for the model to actually process it. So the first thing that had to happen was we got rid of the country name, because the model, the data that goes through the model has to be all numerical, only numbers. You can't have any words or any text in the data. So, and country name is not really that important of a feature. So for predicting anyway. So, you know, like a third world country has the same number of letters and the same length of, you know, the name or whatever as any other country. But then we also took region because that's also represented by text. And what we did is one hot encoding. So now for every region or for every country, there's a one representing that country is of this particular region, and then a 0 for all other countries. So for example, for Finland here, I guess it was Finland, you can't tell, but for Finland's in Western Europe. So Finland gets a 1, there's a 1 under Western Europe column and a 0 under all the other columns. And that was with the get dummies from pandas, pd.getDummies. And then we have, we've removed those column names I just talked about, and then we merged the two together with the pd.concat function. So that is how we've ended up with this particular data set. Now we do the training test split. We are training the model on 75% of the data, testing it on 25% of the data. And we're splitting out ladder score because ladder score is our dependent variable. We are predicting the value of the ladder score given all of these other 27 features. So I'm going to show you really quickly what the data actually looks like. So the X-train, the training data is this. It is 111 of the 149 data points with 27 columns, as I was just mentioning. And now the Y train is a little different here. So the Y train is just the ladder scores. So now we're going to train the model on this, and it will predict the ladder scores given the data that it's had, that it's been trained on. So we're going to build the model. So we have the linear regression model, and just a little Python 101 here again. The linear regression model is a class, which means that a class in most simple terms is thought of as a bundle of functions. So the linear regression, even though it's a model, a machine learning model, from a coding Python coding programming standpoint, all it is a class. And there is a function within the class which does fit. So from the linear regression is renamed as model, and it's instantiated, which means every time you use a class, you have to instantiate it with parentheses. So now we've renamed it as model. So now we're basically from the linear regression class, we're using the fit function, and we're passing the arguments of X train and Y train because that's what it needs to be. It needs an X train and a Y train to be able to do its job, essentially. And the fit is what we call when we're training a model, because training in the gym gets you fit. That's a good way to think about it. So I'm going to run it again. I've already ran it. And fit intercept is true, meaning that the formula has a y-intercept. You can set it to false if you want to not have a y-intercept. For this case, it wouldn't make sense because our lowest score is at 2.3-ish. So obviously there's got to be somewhere to start from. And now we're going to get the score to see how well the model actually performs. So we're going to do X test and Y test. Y test. So we're going to get the score, and we get a score of 99.999 and a bunch of other decimals. And the thing I want to point out here is this data is often, or can be thought of as canned data. It's just a data set off of Kaggle, so it's very clean, and it's pretty easy to get really high accuracy with something like this. In the real world, a lot of times your data is a lot harder to collect, takes a lot more, you have to do a lot more to it to get the model actually, get the data actually ready for modeling. And also it will very unlikely perform, is very unlikely to perform that well. So don't get your hopes up too much is all I want to say. So yeah, that's the video, guys. Thank you for watching. And like I said, I'm offering some tutoring sessions, so you can schedule a session down in the description below if that's something you want to do, especially if you would like to learn more about the whole classes and functions and basically more in depth about what I've just talked about in this video. So yeah, that's it for now, guys. See you in the next one.